It feels like the old days when I would go find a video and respond to it and tell you all how I understand it. What in the absolute garbage am I listening to with this video? PBS SpaceTime, you have gone from only understanding particles as maybe a wave or maybe it's a particle. Now you're saying it's both, but then you also forget to. What the hell's with this app? Get out of here. Stupid. There we go. Okay, so here's what genius space-time people have finally decided to talk about. It's not many interpretations of worlds and pilot wave theory. It has nothing to do with that. They spent the entire time of 16-ish minutes or whatever talking about, get this, the double slit experiment once again. And they do it badly again. I'm sad. I'm sad, okay? Let me explain to you why. First of all, the double slit experiment is created with slits pretty much similar to the size of the electron themselves. Meaning, if you actually zoomed in and simulated it as anything other than a block with slits in it, you would actually notice there's a bunch of atoms with their own electrons in there. Each one of them has their own electromagnetic bubble around it of its own influence, and that the electromagnetic field from the corpuscle,
and the guiding equation then forces the electron corpuscle to remain in.
Shut up! Shush! Just say particle like a smart person, please. I don't want to hear corpuscle. That fucking word is stupid. You made it up just so you could say the same theory or similar or slightly adjusted theories. I've been waiting for you to get it right for so long. Why don't I simulate it? Okay, maybe one day I'll do a simulation where I actually show you what it is, or an animation or whatever else, so I can explain to you what happens in the double slit experiment. Imagine there are a bunch of the walls of the double slit are made by balloons. Okay? The double slit itself is made of a bunch of these atomic particles that are so small their electromagnetic fields are wobbly because the electrons are going around them, and if you were to do enough simulations tracking exactly, or experiments tracking exactly where the photon or electron, totally different by the way, if you were to track where they go and then time lapse it and then properly do trajectory analysis, you would end up finding out something amazing that has nothing to do with this whatever wave theory bullshit. You almost had it. You were so close to having it. You're trajectorying where they're coming from. Guess what? If you also add in the factor of what the heck could be at that specific point to bounce the particle, I'm not going to use that word. I refuse to use that word. Okay? I refuse. I have this guy's emotionally scarred face. His sadness is my own. I'm tired of it. Like, just put a bunch of particles there that are making up the double slit because you're actually looking at it at the proper zoom with proper rendering that shows particles making it up. And then imagine the electrons and then have it go really slow, and then imagine that a particle goes by, and guess what? If the electromagnetic field of the electron that's going around next to the double slit, you would end up with a little bit of a bump that that particle, photon, whatever, is bumping against, and that pushes it slightly. Not to mention the fact that there is this electromagnetic wave resonance. We see the wave and we're like, "Oh, this makes sense. So it must be a wave." And it's like, "No, it must have a particle." Now they're saying it must have a particle. I don't know when he says it, but he says it at some point because he's talking about all these little dots that are like going places and bouncing off of something. Wonder what that could be. It's another electromagnetic field emitting item called the electron, or the atoms itself, which also have their own electromagnetic fields, can give a little push or it can give a little pull. And either way, the effect is enough that you'll end up with the distribution pattern that you're expecting. The waves guide them in that, and you can find this kind of bouncing if you just simulate it with actual particles being where you expect them to be in the double slit walls themselves. That purple thing that they're shooting it through.
But the corpuscle riding...
Shut up! Stop it! Gross! I hate it. I don't even care. It's a particle, okay? You're dumb when you say that. It's gross. It's not gross because the word corpuscle has the word pus in it or whatever. It's gross because those are words for particle and you're not using it. You're using some other word because you're trying to think of the particle of photon or the particle of electron, the little dot thing that we actually notice when we look at the detector. That little dot thing exists, but there's also the electromagnetic field itself. As you're moving, shooting these photons or electrons, whichever one you're doing it with, it doesn't matter. Sort of. They're basically the same difference, only the photon is a lot smaller. You would expect electromagnetic fields to not do that much, but they do. So it's obvious to anyone who has a brain, but you don't, because you made this video 6 days ago. 6 days ago. And you still don't understand how to properly even visualize it correctly. And then you go off saying you are an educator for science. But also, you mask it. Oh, double slit experiment. Yeah, we'll talk all about that. And we'll say something about many worlds and the pilot wave theory. If you actually looked up what pilot wave theory means, you would know it has nothing to do with the double slit experiment. And many worlds is just like you're trying to just say, "Oh, I know something about science because I mentioned double slit experiment." You've made how many videos that include this? But the problem is when you try to talk about many worlds, do something else. When you're trying to talk about many worlds, don't go into making another Toy Story movie. Look at Zelda and the many worlds interpretation of that. Because in Zelda, you have the idea of he failed or he succeeded. Or in the other case, where he did succeed and he does this, and he succeeds and he does that. Or he failed and this happens, or he failed and that happens. And there are different ways, and everyone knows about the freaking... So the timeline is split into multiples, and then collapses again, and whatever else. That is many worlds interpretation of how you can have multiple universes and whatever else nonsense. But pilot wave theory, if you actually look it up, it's not this. The whole fact, I've mentioned this on, you know what, I bet you they killed my channel because of this. Because they don't want people to actually know how the freaking slit experiment actually happens. They want to hide it under all this obscurity of, oh, it's a solid block of freaking wall. There is no such thing as a solid block of freaking wall. The protons in the wall are pulling, the electrons in the wall are pushing. You're likely going to be influenced by the push of the electrons. Where you get trajected into whatever direction these particles are going is because of the electron and where it was at the instant the photon was going through that point. And the electromagnetic field around the electron goes with it, so you get these waves. You can also notice my flat out statement was fail, but you almost got it. This is my full statement. Simulate it correctly. The double slit is made out of particles. You need to simulate the little dots with the little auras around them that they all have because they're freaking particles with electromagnetic fields around them. That's how science actually is done. You analyze it correctly, you create a correct analogous of what it is you're looking at in the simulation. You don't put in a freaking solid wall. This solid wall interpretation of reality is not how it works. No one has ever thought of it that way who has ever considered this in a legitimate fashion. Any actual scientist, if they don't understand that the solid wall is made of particles, you're stupid and you're not a scientist. So whoever gave you this information so you could put it on SpaceTime, and are you a scientist, Mr. Man? I don't know if he's an actual scientist, because he gets it wrong so much. And I wouldn't be this bothered if I didn't also look through the videos of SpaceTime as they come up and find out, oh, he's mentioning this double slit experiment again. Every scientist is always talking about the double slit experiment, because it's the one scientific thing that they can think of that they can then draw inspiration from. But add in this little buzzword of many worlds and plot theory, being the same theory, and it's like you get this whole idea of, well, there's a superposition of your computers and you observing whether or not there's a corpuscle particle. Where the fuck is it? This junk. This freaking junk. Look at this junk. What is this?
Will in turn excite neighboring electron wave functions all across.
See, when you talk about things we don't observe, you're wasting time. When you talk about things we do not observe, you are wasting time. Unless, of course, the idea entirely is that the stuff that we don't observe is the stuff that other people observe in the other universes, in which it does happen there. Okay, then. If you want to have it be like that, sure, you can imagine it being like that. There's nothing wrong with that idea. That in this universe it happens this way, in this universe it happens that way. But that's a little bit more overcomplicating it. all you have to do is say, hey, it bumped with this trajectory. Maybe if it bumps in this method, in this way, we can extrapolate what could have bumped it in that way and actually show you that. But they don't show anything. And why haven't I made the animation yet? I don't know. It's been years. I could have made the animation to properly show you what the hell the double slit is actually doing on an atomic level. And all I have to do is have some wobbly bumps. That's it. Just some wobbly bumps. And that's all it would be. And as your particle goes through, those wobbly bumps might bump into it, sending it in the direction we expect. And that's why sometimes they'll go to the left, to the right, to the whatever. And it's all random-ish. That's because the particles are moving at whatever speeds, and then coinciding with the electron or photon as it's going through the double slit experiment is going to happen only sometimes. Because that's how the arrangement is sometimes. And if you were to pay attention to that, you'd understand how it's happening. The double slit experiment is almost like shooting a balloon through another set of closely knit balloons. You're going to get bumped. But there's a gap between the balloons. We call that the slit. Oh, and the balloons are moving around in circles. And the balloons are more solid, and when you actually look at them, it's not balloons that you're pushing through stuff. The outer edge of the balloon represents the electromagnetic field and how it can interfere with other stuff. What is actually going through is a BB that is like tied to a balloon or has a balloon around it, outside of it or something. The analogy of balloons is failing me. Okay. An aura of electromagnetic field is around the particle, and we understand this because it's how the electrons are able to connect to an atomic particle in the first place. Atoms have electrons around them because there's an energy transfer between the electrons and the protons and neutrons that are the particle itself, or the atom itself. We understand this. We know there's this electromagnetic connection between the electron and the protons and neutrons. And because of the neutrons mostly, or the electron's negative effect, the protons have all the positive effect. They're trying to pull the electron in. The electron's like, nope, you got too many neutrons in there. And also, just no. It doesn't quite make it there, and it's also orbiting at a crazy speed. How fast? Like thousands per second. Or millions. I don't remember the number. But it's so fast that if you try to simulate it, you just find it to be a kind of weird blur. But if you slow it down, you notice the blur is similar to how a planet orbits the star. It goes up and down, wobbling. And that's motion. That's the motion of how you're moving through the solar system right now. Yeah, it doesn't go in a straight orbit. It goes up and down, up and down, up and down. I saw that video too. That was fun. It's a fun video. More realistic than any of this garbage. I'm sorry, I shouldn't keep on saying garbage and stuff. Where the hell is it? It's down here somewhere. I watch a lot of videos, okay? Watch a lot of videos. The last science video with the freaking orbit was like, where is that spirally dude? Where is it? Spiral, where are you? I know you're here somewhere. I know you're here. No way. What? Did I pass it? I may have passed it. Where is it? Where are you, spirally douchebag? I don't know where it is. I'm trying to find it. I'm kind of lost. I watched a lot of stuff recently. This video is not the only thing. There it is! That! And it's not even a spiral. This video talks about how an orbit of a planet... Shut up. An orbit of a planet is not a straight line, even a curlicue. It's a wobbly curlicue. Right? That's fun. That's neat to know. Maybe BBS SpaceTime needs to watch a Kirksey's video so he can end up finding out about reality a little bit more. And then when you find out about reality, you find out it looks like this. Look at all that. It's sideways and it's wobbly and stuff. We go around like this, which is crazy. Oh yeah, there it is. It's about to show up. That it looks like this.
Years long. We haven't mapped this motion out completely, as it takes.
Yeah, that's how the wobbly stuff happens. And then if you understand that and how motion works on a basic level with some attraction and an item that's going around just randomly, then you can apply that kind of same logic to atomic particles, and you can know where the freaking stuff is. Yeah, you can find out where the electron is. If you look at something as big as this, and you can find out the wobbliness of it.
The solar system tens of millions of years to go up 10 times every orbit along arcs thousands of light years long.
Look at that. It goes up and down, up and down, up and down. It's like, if you think about that, but instead of a big galaxy, it could also be the same type of motion as electrons, then you understand it a lot more. You can simulate it better. You can find out where it's going. But it's still going at incredible speed. So you're not gonna see it so easily. You are not where you think you are. And then I see this. Now what am I expecting to see when I looked at this PBS SpaceTime video? I'll tell you one thing, not a double slit experiment! Wasn't expecting to see a double slit experiment. I hate it. That's what I ended up seeing. It's like you go and you can bring up a topic. You bring up, instead of actually explaining the topic, you bring up some other thing that you still don't have right, because science is like slightly behind the 1950s or something. Or whenever we ended up thinking about when electrons and protons have their own electromagnetic fields and stuff, and we understand this on a fundamental level, and then you're still not using that same logic 70 years later? What? This is a Science Me video. I'm not usually this pissed off at science communicators, but when I am, holy crap. Please stop being wrong. Just stop being wrong. It's not even that much to ask. You know how particles work. You do know. You do know. If you don't ask me, I'll tell you. I've been at this for ever since it's been YouTube. I've been at this. My other YouTube channel was removed, and it's probably because I knew too much. Started talking about how nowadays I'm starting to talk about how, like, you can pair a one-dimensional being and a two-dimensional being, and then you compare the 2 dimensions of a box or a square to the 3 dimensions of a box. It's like you're expanding it out that much. When you go to the 4th dimension, my true interpretation of a 4th dimension is that it's adding another. It's not actually as grandiose as they think it is. It's just another interpolation outward. But not outward. Because you have the three-dimensional space that we normally experience, right? But now you have to think about that times another multiple. Because you think about the area of a square, right? And then if you think about the areas of the cube, and there's like 5 more of your original two-dimensional space in that cube space. And a four-dimensional is turning that 6-sided die, and it's turning it into some crazy thing, which has other stuff. And you know how you work that out? I'll talk about that in another video.